Hi guys, you're going to need a blank piece of paper today. It could be all white or it could be lined, it doesn't matter. And you're going to fold it as your hot dog style. Go ahead and fold it, and then you want to make sure that your flap is where you can open it is on the bottom. You're going to go ahead and just take a ruler, or you can kind of guess like where the kind of even spot is on, you need 3 different sections. You can either cut them on this line that I'm drawing here, or you can go ahead and just keep the lines, okay? So I'm going to go ahead and cut mine just so I could show you guys what it's actually supposed to look like here. And then, once you have cut it, we're then going into the 3 different sections. We are then going to grab something to write with. So this one is going to be called one solution. Okay, so when we have one solution, we're going to go over this now. We're going to do an example inside here of 2 different types that you'll actually see. So we're going to go ahead and flip this up. If you didn't, just make sure you put the lines on the inside of your paper as well if you didn't cut this. So then you'd have lines following this all the way down just to make sure that it's straight. Okay, and I could do that here. Okay, so our first example on the top, we're going to do 14 equals 2x minus 6. So right now this is just a 2-step equation. We're going to add 6 to both sides, and we have 20 equals 2x, and we're going to divide by 2 from both sides in order to get x by itself and equal 10. I'm okay if you guys leave your answer like this, or you can also switch the sides and make sure you have the same sign and it keeps it like that. So this right here, if we have x equaling a number, this means that we have one solution. And this is x equaling a number. It could be any number as long as, or your variable even, as long as it's equaling one number. Now, you guys might see some ways where I might actually give you a number. So say we have x equals 10. We can also just check our solution too. We have x equals 10, and my original equation was 2x minus 6. So if I say, does this have one solution, infinite solutions, or no solutions? And you guys would actually plug in this x equals 10 into the x of our formula. And we're going to actually test that out and see. So I'm going to plug that in for x equals 10 there. Sorry, yeah, x equals 10. So 14 equals 2 times 10 minus 6. So now I have 2 times 20, which equals 2 times 10 is 20, minus 6. We get 14 equals 14. Yay! If we have solutions equaling each other, then our numbers, we do still have one solution, and this is a correct solution. So there will be 2 ways you guys can tell me if they have one solution or not. Okay? Now, I'm going to go back to the top here. We're going to go to the middle row, and now we're going to do no solution. So on our one solution, we had x equaling a number. On no solution, we have a little symbol like that. X can, that means that there's no solution. So now we're going to go ahead and I'll show you an example. This is where even like a number might equal a number. That might be one of the cases. So let's open this up so you can actually see an example. We're going to write on the top here. And my first example I'm going to go over is 10x minus 3x plus 4, which equals 7x plus 9. So these are our variables on both sides. Our first step we need to do on this left side is to make sure we can combine like terms, because I know I have a like term here of 10x and another like term of negative 3x. So we have 10 minus 3, which is 7x. That 4 does not get to combine with anything else. And on the right side, we have no like terms I'm allowed to combine because this has an x and this does not. Now, I'm going to go ahead and solve for x. So I'm going to try and get one of my x's on the other side. They happen to be the same, so if I subtract 7x, oh, all of a sudden they disappear. Those cancel and those cancel. I'm left with 4 equals 9. This is where I want you guys to stop because 4 can never equal 9. So if you put a little slash through that equal sign, it means it does not equal. And so if you had $4, that doesn't mean you have $9. So that means that there is no solution. So you guys do have to work the problem all the way down to here to see that you actually get a number equaling a different number. Now, if we were to try and check our work on this and try and see if a solution actually worked, then no number would actually work. So if you guys, let's say for example, if we tried x equals 1, if we tried plugging that in to our original formula here, then this would actually not work, but I'm going to show you why. So if we go ahead and actually plug in the 1 everywhere that we see an x, I'm going to go ahead and combine like terms again just to make my life easier. So we're on that second step there. And then now I'm going to take that x equaling 1 and plug that into this x and this x. Okay, so let's see what happens. If we do 7 times 1 plus 4 equals 7 times 1 plus 9, 7 times 1 is 7, plus 4, 7 times 1 is 7, plus 9. So if we get 7 plus 4, we get 11 on this side, and 7 plus 9, we get 16. Again, the numbers don't equal each other, so therefore they will be no solution. Okay, moving right along, so actually we should put a little slash through this then too. A number cannot equal a number, a different number. Let's say number 2. Number 1 cannot equal number 2. Okay, so that was our example. Now we're back on the front of our screen, and we're going to go to infinite solutions. And infinite solutions, I don't know if you guys have ever seen this little figure 8, that's an infinite symbol. So let me show you guys an example of this. Open this up. Our example, we have negative 5 plus 3x equals 2x minus 5 plus x. So again, we're going to check that left side. We have variables on both sides, so check that we don't have any combined like terms or any like terms here to combine. We don't on this side, so I'm just going to rewrite it. On this right side, we actually do have like terms. We have 2x and x. So I have 3x minus 5. And now I'm going to go ahead and try and get my variables on one side. So my variables, I have negative 3x. Oh, look what happens. They were the same again. So now I get negative 5 equals negative 5. Oh, well that is true. If I were negative $5 in debt, that means I have negative $5 in debt. So if you get a number equaling the same number, then this means that you have infinite solutions. Which means that every number that you plug in here will actually work. So let's, for example, so I'm going to open this one. Let's say, little key point for our middle one, no number will work. That was for this is for no solution. So no number will work. On here, every number will work that we plug in for x. Every number will work. Okay, so let's just do for an example. Let's pick a random number. Let's say x equals 25. Why not? So if we have negative 5 plus 3 times 25 equals, so again we're plugging this in. Let me rewrite our original equation up here. Equals 2x minus 5 plus x. So again, I am plugging this 25 in for every single x that I see. Okay, so now I have a 2 times 25. I might run out of room. Negative 5 plus 25. Squeeze it in there. Let me zoom in so you guys can see. So negative 5 plus 3 times 25 equals 2 times 25 minus 5 plus 25. So I have a negative 5 left over here. 3 times 25 cents, you have 75 cents. 2 times 25, that means I have 50 cents. Minus 5, and then plus 25. So now we're just going to kind of go through and combine like terms. 1 on the left side, 75 minus 5 is 70. 50 minus 5 is 45, plus 25. I'm going to do it one extra step, which means I have 45 plus 25. That should also be 70. Check. We got the same number equaling the same number. So awesome. That means we have infinite solutions. And again, I'm just going to kind of draw a symbol. So this one we had 2 different numbers that don't equal each other. Here we have the same number equaling the same number. All right, you guys, that is it for your notes. We'll see you next time.